Hello friends, welcome to lecture number 2 of wave. In first lecture what we discuss? Introduction to wave. What is wave? How energy transfer without any motion of matter. That is the wave. We also did the classification of wave. Mechanical, non-mechanical, gravity wave, matter wave, and also we will classify the wave into another two types. Irrespective of mechanical, non-mechanical, has no relation with that, but again we will classify the wave into two more types. Now let's see what are the two more types. Wave classified into two types. One is transverse wave. This one is longitudinal wave. Transverse wave and the longitudinal wave. What do you mean by transverse wave? I told you in the previous class, wave means two things. Oscillation plus propagation is called as wave. So transverse wave means how we classify this transverse and longitudinal depending on the direction of oscillation and propagation. So the wave is transverse if oscillation perpendicular to propagation. Oscillation perpendicular to propagation. What happens in case of a water wave on the surface of water? Suppose here particle oscillate in this direction. This is y-axis. Particle oscillate along y-axis. Then wave propagate along x-axis. This is the direction of propagation. This is the direction of oscillation. What is the angle between them? 90 degree. So this is called as transverse wave. The wave is transverse if oscillation is perpendicular to propagation. Then how it propagates? It propagates like this, forming this is crest and this is trough. Forming crest and trough, the wave propagates. Which is transverse wave. Propagate forming crest and trough. So what are the examples of transverse waves? Just before I told you, the wave on the surface of water. Water particles oscillate like this and propagate. The wave propagate on the surface of water. So water wave is one transverse wave. Then string wave, wave along a string, that's also transverse wave. But all these are particle dependent. Particles are there. But another example is also of transverse wave, electromagnetic wave, which is a non-mechanical wave, but it is transverse. The question is coming to your mind, sir, how it is transverse? I told you, oscillation perpendicular to propagation. So in electromagnetic wave, do you know what happened? There are three things. One is electric field, one is magnetic field, one is velocity. Wave velocity, and they all are mutually perpendicular to each other. If electric field oscillate along y-axis, magnetic field oscillate along z-axis, then wave propagate along which axis remain? X-axis. So all three are mutually perpendicular to each other in electromagnetic wave. That's why electromagnetic wave is called as which wave? Transverse wave. Because oscillation, electric field oscillation is perpendicular to propagation. No particles there. Electric field and magnetic field oscillate, but perpendicular to propagation. So that's why that is called transverse wave. You know, electromagnetic wave, your visible light is a part of it. You know, light is a transverse wave. But why transverse? Because electric field oscillation, magnetic field oscillation perpendicular to propagation. Then let's come to longitudinal wave. What is longitudinal wave? What happens here? Here oscillation and propagation are not perpendicular Rather, oscillation is along propagation. Oscillation is along propagation. Means what happens here? If oscillation happens like this, in this direction oscillation happens, also wave propagate in that direction. Means oscillation and propagation are in same line, then it is called as longitudinal wave. Both are in same direction. The question is coming to your mind, sir, please give us an example. The best example is sound wave. Sound wave is one longitudinal wave. How sound wave is longitudinal wave? When I am telling something, try to understand. Now, when I tell how you listen, generally what happens in physical class, when you are sitting, when teachers is telling something, teachers is telling means when I am telling, I am exerting on pressure, nothing but pressure. Air particles are here. When I tell something, C, I tell C, O, P, all have different pressure. They exert pressure on the air molecule. The air molecule start oscillating like this. So when the air molecule oscillate, they also oscillate, make oscillate to the next molecule. And then at last, the molecule near your eardrum. When the molecule near your eardrum oscillate, that hits the drum and exert the same pressure, and then you can able to understand the word. That pressure then through the optic nerve go to brain, and that can able to recognize the word. As if one spring is connected from my mouth to your ear, from the teacher's mouth to your ear, like that. When I exert pressure, that travels in air in form of a longitudinal wave. What happens? When I tell C means the air now in front of me gets compressed. It gets compressed. Then again it restores its position, that gets rarefied. When it gets rarefied, it compresses the next air. Again that air first compressed, then rarefied. When again rarefied, that compressed to the next air. So like this, longitudinal wave propagate, forming compressions and rarefactions. Forming compressions and rarefactions. Where the compression, see, this is the compression region, then rarefy. Then compression, then rarefaction. See. So this is the compression region and this is the rarefaction region. Again, this is the compression, this is the rarefaction region. Compression, rarefaction. So longitudinal wave propagate, forming compression and rarefaction like this. Best example is sound wave. So these are the two types of waves. Broadly we will classify the waves into two types, irrespective of mechanical, non-mechanical, like this. So now today we will discuss some terms what we use in wave. Let's come to terminology. What are the different terms we use in wave? First, very common term what we always use in wave. What is that? Let's start. The first important term in wave. So that is the what? Wavelength. Faster. Wavelength. What is wavelength? I think you know this in lower classes, a little bit about this. The distance between two consecutive crest or trough in transverse wave, or between two consecutive compressions or rarefactions in longitudinal wave, is called as wavelength. If possible, you note down this. The distance between two consecutive crests. I am showing in transverse wave, you see, this is the transverse wave. The distance between two consecutive crest to crest distance. or draw to draw distance. This is called as wavelength, and the symbol is lambda. The symbol is lambda, and its SI unit is distance. So obviously SI unit is meter. Dimensional formula L1. Okay, so this is the wavelength, the distance between two consecutive crest or consecutive trough. Similarly, also in longitudinal wave, consecutive compressions or consecutive rarefactions is called as wavelength. Next quantity. Let's come to the next term. Is time period. What is time period? Let's come to time period. Time period term, this is same as the oscillation. Oscillation. In oscillation, what was the expression? Time. What is the definition of time period in oscillation chapter? Time taken to complete one oscillation is called as time period. Time taken to complete one oscillation is called time period. The same definition here. The particle takes how much time to complete one oscillation. But the important thing is here, when the particle complete one oscillation, at that time the wave travel how much distance? Lambda distance. Particle go to the uppermost position, again come to the lowermost position. Particle go to the uppermost position means crest, then come to the lowermost position means trough, then to equilibrium position. When the particle complete one oscillation, then the wave travel how much distance? Lambda distance. So this to this, time taken by the wave, this is a complete crest and trough, to travel lambda distance is called as time period. If we tell the definition in terms of oscillation, time taken by one particle to complete one oscillation is called time period. Or you can say time taken by wave to travel distance equal to lambda is also called as time period. Its SI unit second. Time period SI unit is second. Let's come to the next term. Next term is now frequency. Now it's the term of frequency now. Next term is frequency. Point number 3, that is frequency. What is frequency? So this is new. Frequency is new. So what is maybe new, maybe F, maybe N, many symbols you can use, but I am writing here new. What is this frequency? Frequency in oscillation, the number of oscillations per second is called frequency here. But in wave, what is the frequency? Wave is you just mark a particular point and see there in 1 second how many complete waves pass. Complete waves means crest, trough. This becomes one complete wave. How many complete waves passes through that point in 1 second? That is called frequency. Again, write down, number of complete waves passes through a point in 1 second is called as frequency. SI unit, Hertz. Formula 1 by T. New formula is 1 by T. Why 1 by T? Because when one wave pass through a point, what is the time taken? T. So in T second, one wave pass. In 1 second, 1 by T wave pass. This is called frequency. In T second, one wave. In 1 second, 1 by T number of waves. So that is the frequency. That's why nu is equal to 1 by T. So this is the frequency and SI unit is Hertz. But practically, if you understand the frequency practically, suppose let's compare two waves. The same point, in 1 second the wave pass like this. and in 1 second you see wave pass like this. In same time through the same point the wave pass like this. Now between them, this is number 1, this is number 2. Which one is of more frequency? Where more number of waves passes? First one or second one? Where more number of waves passes? Obviously in the same time. This is the picture I have shown to you through this point. In same time, what is the situation? How many waves passes? Obviously more number of waves passes in the second case. So frequency is high. In which case? Second case. Frequency is more number of waves per unit time. Second case I am telling to you. In day-to-day life frequency, more is the frequency, more is the sweetness of sound. How can you mark that which sound has more frequency or which sound has less frequency? More is the sweetness, more is the frequency. So who always produces sounds of a sweetness sound? Who always produce sweet sound? Who? Bees, small babies, as well as also girls. Their sound is also sweet. So they all produce waves of more frequency. But what about who produce waves of a very less frequency? Who produce? Male persons. Male persons produce their frequencies low. That's why hoarse sound comes. Hoarse sound comes. And what about dogs? I will not tell. Now you will say dogs produce which frequency sound, low frequency or high frequency sound. Okay? So this is the frequency. More is the frequency, more is the sweetness of sound. Remember. So this is the frequency now. Let's come to the next quantity. Next quantity is angular frequency. Angular frequency. What is angular frequency? The product of a frequency with 2 pi is called as angular frequency, which is same as in oscillation. The product of frequency with 2 pi, the symbol is omega. The product of a frequency with 2 pi is called as angular frequency. Product of frequency with 2 pi. Next point, come to the next quantity. Next quantity is now wave number. This is another quantity. Wave number. What is wave number? You take unit distance. Unit distance. Within this much distance, see how many waves are there. 1, 2, 3. How many waves are there per unit distance is called as wave number. Right? Number of waves per unit distance is called as wave number. Then what is the formula of wave number? You see? Okay. So when one wave, complete one wave, then what is the distance? Lambda. So in lambda distance, one wave. In lambda meter, one wave. In 1 meter, 1 by lambda number of waves. So what is wave number? 1 by lambda nu bar. Symbol is nu bar. So nu bar is equal to 1 by lambda. This is called as wave number. The number of waves per unit distance is called as wave number. Next, what is angular wave number? Next quantity is angular wave number. Let's come to angular wave number. Angular wave number. The product of wave number with 2 pi is called as angular wave number. Product of wave number with 2 pi. 2 pi nu bar. The product of wave number with 2 pi is called as angular wave number. But nu bar, What is the symbol of this? K. We write for angular wave number, the symbol is K. So 2 pi, numerator is 1 by lambda. So this is 2 pi by lambda. So K is equal to 2 pi by lambda. Remember this formula. This will be required. Remember must. So wave number, angular wave number K is equal to 2 pi by lambda. This K is also called as propagation vector. Remember. This K is also called as propagation vector. And it's 2 pi by lambda, angular wave number. So these quantities are required when we will enter into this topic. Another quantity will not leave. That is also important. Which quantity? That is amplitude. Amplitude we should discuss it first. That is amplitude. What is amplitude? That is from oscillation directly. The maximum displacement from the equilibrium position on either side is called as amplitude. The maximum displacement. If this is the wave, this is the equilibrium line, particles are here in equilibrium position, but maximum displacement on either side is called as amplitude. Amplitude is measured in unit meter, as a unit meter, centimeter. You can also use like this. So this is the amplitude. So we discuss now the many quantities. Then another important quantity what we are going to discuss. Remember, that is very important. Wave velocity. This is very important now. Wave velocity. I told you, in wave there are two coordinates. There are two velocities. How? Because particle oscillation and wave propagation. This is oscillation. This is oscillation. And this is what? Propagation. But in oscillation happens in this line and propagation happens in this line. Particle is not moving. Particle is doing only oscillation. In oscillation you have read the velocity of the particle. Is that constant? Is the velocity of oscillation constant? The answer is coming from you. I know that yes, velocity is not constant. Velocity is not constant. You are thinking this answer. Then good. You know, in oscillation, the velocity is maximum in which position? Mean position. 0 at extreme. Extreme to here 0, maximum, 0, maximum, 0, maximum. That means velocity varies when the particle is doing oscillation. So velocity of the particle varies. 0, maximum, 0, maximum, 0. Particle velocity varies. But what about wave velocity? But wave velocity is constant. Wave velocity is constant. With the time, it remains constant. As long as the wave is in a particular medium condition. When medium changes, wave velocity also changes. But in a particular medium, wave velocity remains constant. But particle velocity, oscillation velocity change. So you got now, you understood now another difference between oscillation and wave. In oscillation, particle, so in wave two velocities are there. One is particle velocity, one is wave velocity. Wave velocity is also called as phase velocity. This is also called as phase velocity, which is constant. So in case of wave, there are two velocities. Particle velocity, which varies, increase, decrease. But a wave velocity, which always remains constant as long as the wave is in a particular medium. Okay. So now see. So this is about the wave velocity. We find the expression of wave velocity. Very easy, we can able to find out. How you find the expression of wave velocity? See, this is one wave, one complete wave. When generally we find velocity, this is velocity wave. So velocity or speed, we can say that is distance or displacement. I write displacement, okay. I have taught velocity, displacement by time. In one complete wave, what is the displacement? Lambda. This is the lambda. For the time taken, capital T. So you have distance, you have time, then you have velocity. So velocity of a wave is equal to displacement lambda by time t. So it's lambda by t. But in place of 1 by t, we can write here nu. We can write here nu. Then what about wave velocity? Write the symbol like this. What about wave velocity v? V is equal to nu lambda. This formula is most required not only in 11th as well as in 12th, everywhere. Remember, velocity of wave is equal to its frequency into wavelength. This is the relation between three more primary quantities of a wave. V is equal to nu lambda. Always remember. Okay, so this is the wave velocity or phase velocity. We can also express it in another form. Now you see what I am doing here. 2 pi, you just multiply, and 2 pi you divide. Multiply and divide. Then what you see here? 2 pi nu divided by 2 pi by lambda. 2 pi nu, this remain. Then 2 pi by lambda. I just bring the lambda to this side. So what is 2 pi nu? What is 2 pi nu? 2 pi nu is omega. What is 2 pi by lambda? This is k. You got also another relation for wave velocity or phase velocity. V is equal to omega by k. Angular frequency divided by angular wave number. This is also the velocity of wave or phase velocity. Now you understood, in wave there are two velocities. One is particle velocity, one is wave velocity. Particle velocity which always varies, wave velocity which always remains constant in a particular medium. And V is equal to nu lambda and V is equal to omega by k. Now let's discuss velocity of a transverse wave and velocity of a longitudinal wave separately. Now let's discuss the velocity of transverse wave and velocity of longitudinal wave separately. Velocity of transverse wave, string, in a string, you just tie one string tightly, then disturb at one position. Immediately one wave travel in the string. Okay, one wave travel in the string. Sometimes when the wave travels also sound comes due to vibration. So what is the velocity of a transverse wave? Now let's discuss. It can be one also 3 marks question. Velocity of transverse wave in a string. Velocity of transverse wave in a stretched string, I told. Okay, when the string is stretched. Then this velocity depends on 2 factors. Velocity depends on 2 factors. One is tension along the string. Tension, when you tight it, then tension comes in action. Then mass per unit length, remember. Also depends on mass per unit length. I wrote the symbol mu. Remember, this is not mass, this is mass per unit length. Okay, don't misunderstood it as mass. This is mass per unit length. That's why I use the symbol mu. Okay, so mu is, remember, mass per unit length. I am telling repeatedly this one because many students do the mistake. Some books write the symbol in place of mu as m. If I write m and I will tell mass per unit length, sometimes you may do mistake. That's why I change the symbol to mu. This also in some books they write. This is the more mature symbol. Okay, we'll use better to avoid confusion. So If velocity depends on tension and mass per unit length, then what is the expression for velocity? Is it required to do? You have already done it. In which chapter? Dimension chapter. Okay, then you can try it better. So you first pause the video here, then you try. First pause the video and try. Do quick. Don't do late. Pause it. Okay. So hope you derived the relation of velocity. Now you check whether you have done correctly or not. Now you check it. I am doing. Velocity proportional to t to the power a, proportional to mu to the power b. Like this you have done. If done, then it's good. Then one constant k, t to the power a, mu to the power b. Then you write the dimension in both sides. m0, L1, t minus 1. K is dimensionless. Tension is the force. So m1, L1, t minus 2. Tension is the force. K is dimensionless. Power a. This mu is mass per unit length. Remember, this is mass by length. So mass per unit length. So this is power b. Then m to the power 0, L1, t minus 1, m to the power a plus b. Then L to the power a minus b, t to the power minus 2a. Let's compare the dimension of t. It's better. First compare t dimension. Anyone you can compare, no problem. Minus 2a is equal to minus 1. So a is equal to half. Yes. Then you compare m. It's better. A plus b, here 0. Here power is a plus b. Here power is 0. A plus b is equal to 0. So a is half. Half plus b is equal to 0. Then what about b? Minus half. Got it? I hope you also got this answer. Okay, it's good. Then now put it here. In this formula I will put. So v is equal to k t to the power half mu to the power minus half. B power. So this is k. Then t by mu root over velocity. But you know what you'll do with k. So k, experimentally k is found to be 1. So v is equal to t by mu root over. So this is the expression of a velocity in stressed string. Expression of velocity. Hope you also got the same answer. If you got, then very good. If not got, then also good. You try. Then next, this is the velocity of wave in a stressed string. Velocity of transverse wave. But what is the velocity of transverse wave in solid? In solid, what is the velocity of transverse wave? That one was about string only. But what happens to the velocity of wave in solid? Velocity of transverse wave. It depends on two factors. What are the two factors? Rigidity modulus. Depends on rigidity modulus. Eta. Just recall eta. Okay, where you had read this in elasticity chapter, just recall eta. And the density. Density means volume density, mass by volume. So velocity of wave depends on rigidity modulus and depends on the density. In solid medium, velocity of transverse wave. Okay? So now, then what do you have to do? Are you expecting that I will do this answer? Not at all. This is up to you. You will solve it. Okay? You solve and you see, and at last you see your answer. V is equal to rigidity modulus by density root over. You will get this much expression at last. You do it. I will not do at all. So this is about the velocity of which wave? Transverse wave. Now we'll discuss velocity of which wave? Obviously, longitudinal wave, transverse wave completed. So velocity of longitudinal wave now discuss. What is the velocity of longitudinal wave? Depends on which factors? Depends on Bulk modulus depends on density. This also depends on the bulk modulus of elasticity, okay, as well as density. The velocity of longitudinal wave in a medium. Velocity of longitudinal wave in a medium depends on these two factors. Who will derive the relation? Again I will do. You pause the video here. First try. Try it. Quick. Pause. Don't do late. Fast. Okay. So, hope you got the answer. Now, let's see. I am doing it for you. Don't worry. You will check the answer at last. So, b to the power a, that is rho to the power b. Then v is equal to constant. B to the power a, rho to the power b. Then v is m0, L1, t minus 1, k is dimensionless. This bulk modulus, you know bulk modulus is stress by strain. So this is stress by strain. Strain has no dimension, so only stress. Otherwise I am writing here. So stress by strain. Okay, strain has no dimension, only stress. And stress is what? Force by area. So its dimension is m1 L minus 1 t minus 2. m1 L minus 1 by t minus 2. Then rho is mass by volume m1 L to the power minus 3. So this is power A, this is power B. Then m0 L1 t minus 1, this is m to the power A plus B L to the power minus A minus 3B t to the power minus 2A. Then you compare both sides. As usual, first compare t, it's better. Minus 2A minus 1. So A is equal to half S. Then compare M. Okay, A plus B, here 0. So A plus B is equal to 0. So B is equal to minus A, means minus half. It's not required to compare again L. You will also get the same answer, no problem. Okay, so this is half and minus half. Now write the expression. So V is equal to B. So here you put K constant, B to the power half, rho to the power minus half. So K, B by rho root over. This is the velocity. But again, experimentally K is found to be 1. So V is equal to B by rho root over. So this is the velocity of your longitudinal wave in a medium. Got it? Velocity of a longitudinal wave in a medium. V is equal to B by rho root over. Hope you got the answer. So in this way, we will find the velocity of wave. But what is the velocity of a wave? What is the velocity of a longitudinal wave? This is a medium. What is the velocity of longitudinal wave? In gas. What is the velocity of a longitudinal wave in gas? What is the expression of it? Okay, that one we'll discuss in next lecture. Thank you.